Okay. Next part, we're going to look at maxima and minima problems. So we've been talking about differentiation already. Differentiating and setting things equal to 0, that's what we do when we have a minimum and we have a maximum. And it's quite useful because if we wanted to find, say, maximum velocity, if there is a maximum velocity, that implies that it goes up and up and up and up and up, and at some point it reaches its maximum. So after that, it must go down and down and down and down. Well, if you differentiate velocity, you'll get acceleration. So when the acceleration is equal to 0, you'll be able to find this peak, this maximum velocity. Okay, so it's quite useful to differentiate and set it equal to 0 when you're trying to find different things. So a child's playing with a yo-yo. The yo-yo leaves their hand at t equals 0. It travels vertically in a straight line before returning to their hand. The distance, notice it's distance here, so it's always going to be positive. Okay, their distance is given by this. So the distance is blah, 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 blah. Notice when t equals 0, the distance equals 0 because it's leaving their hand. And in fact, look, that's the first part there. Why are we doing this? Well, we're doing this because 0 is the start, it's time, it cannot be negative. Okay, 3, why are we using 3 seconds? Well, why don't you put t equals 3 into this, and it might make a bit more sense. I suspect that the distance will be 0. Okay, in fact, look, there's 0 and there's 3, and we're ignoring all of this. We're only interested in this small window here. Okay, we cannot have negative distances and we cannot have negative time. So that's why we've got this restriction. What's the maximum distance of the yo-yo? Well, if this is the distance graph, the maximum distance is at that peak point there, isn't it? One way you could find this is you could think of it as a turning point. So you could differentiate it and then set it equal to 0. Differentiate what? Differentiate this displacement equation. So if we differentiate displacement, we'll get velocity, which will be 0.6 plus 0.8t minus 0.6t squared. And then a turning point, you set it equal to 0. You might remember we've said before, v equals 0, one of the most common times to use that is when something changes direction. So it's moving away from your hand, and then it starts to go back to your hand. So that moment in between where it changes, the v is equal to 0. That's another way that you can think about this. So you're going to solve this one here. Okay, you just need to solve this one here to finish with. And you end up with 2 values for time. It's allowed to be messy, you're allowed decimals and so on. You end up with 1.865. It did actually say the maximum distance, didn't it? The maximum distance. So when you know your time needs to go back into the distance equation, and that should give you your answer. So there we go. Differentiation and setting it equal to 0 to find a maximum or a minimum is useful for mechanics as well. Pause the video and have a go at those questions there on the board. And I encourage you, before you jump into something too much, think about what these phrases really mean. Think about what maximum velocity really means and where it might be. So pause the video, have a go. Okay, when does it reach its maximum velocity? So maximum velocity implies that velocity is doing something like this, right? And it reaches some value and then it starts to go down. So the maximum velocity is when it starts to turn. So you need to differentiate your velocity. And that's the same as finding the acceleration. When you differentiate it, you're going to set it equal to 0. So you can think of it in 2 ways. You can think about differentiate the velocity and set it equal to 0, or you can think of it as finding your acceleration and setting it equal to 0. They are the same thing. So we differentiate to get this one. the dolphin, its velocity as it blah, 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 blah. Yeah, we differentiate velocity with respect to time, and we get this one here, and we solve, and we get 8 seconds. So this is happening, this maximum velocity is happening at 8 seconds. When does it happen? It happens at 8 seconds. What is it? Well, you've got to put the 8 seconds back into the v equals equation up here. You have to put that back in, substitute it back in on your calculator. This one over here, when is it instantaneously at rest? Well, that means v equals 0. So step 1, set it equal to 0 and solve. The times, it said times, so there's 2 answers. That makes sense. What about the greatest speed? So we just talked about this. Velocity, look, it's also a positive quadratic, so it's something like this. It starts at 20. So I know that that's 2. I know that that's 5 seconds. I know that this is velocity. Where will the greatest speed be? Greatest speed means it could be above or it could be below. So I have to check 0. I can check 0. That's going to be 20 from the intercept. I know it's not either of these, but look, it could be that point there when it goes into its negative by the maximum amount. So I can use some symmetry to work that out, or again, I could differentiate this thing, which is dv over dt equals 40 minus 14. I could set it equal to 0, so 0 equals 40 minus 14. 7, so it's 7 over 2, so it's 3.5 seconds. Okay? That's when this thing is happening, 3.5. I could have used the symmetry of the points as well. Put that one back in there and find out the number, and then we just need to know, is it more or less than 20? So it is less than 20. It's minus 4.5, so it's not big enough. So 20 is the biggest speed throughout there. So it's the it's the biggest speed. It's the biggest speed out of the positive and the negative. Okay, 11C is the exercise now to have a go at in the book.